That don't even be yours. You doing all that for what? And you in your pocket.
Now, while that video is hilarious, it is just a skit. And I'll say once again, that's not how electricity works. So why do I say that? Let's get into it. In this video, it looks like the whole fence should become electrified and shock the man leaning on it whenever she engages the fence with a stun gun. But that's not how the circuit is set up, and that's not how electricity works. You see, a stun gun creates a large voltage difference between its two electrodes. When both electrodes contact a person, that voltage difference drives current through the body from one electrode to the other. Here, both electrodes are touching the same metal fence. See, the metal gives the current a conductive path from one electrode of the stun gun directly back to the other. So the fence is actually being shocked, but only through that small piece between the two electrodes. The person farther down the fence is not being placed between those two high voltage points. That's the important part. A shock requires a significant voltage difference across your body. Simply touching metal that has current flowing through part of it does not automatically mean current will flow through you. Now, a lot of you have mentioned an electric fence. An electric fence works on a very similar principle. The big difference is where those two electrical reference points are located. With a stun gun, the current is trying to get from one electrode on the gun back to the other electrode. With an electric fence energizer, one terminal connects to the fence wire, while the other connects to a ground electrode buried in the earth. So now those 2 points are separated. One is the fence wire, and the other is the earth. Both nodes, just like the 2 posts of the stun gun. When you stand on the ground and touch the energized wire, your body completes the path from the fence, through you, into the earth, through the ground electrode, and back to the energizer. That's also why electric fence wire is mounted on plastic or other insulating standoffs. If the energized wire were allowed to make solid contact with a grounded metal fence, like the fence in the video, the circuit would already have a return path through the grounded fence and soil, so the voltage on the energized wire would drop substantially, and you would feel little, if any, shock. So even though the two systems are similar, the reference points are different and key. With a stun gun, both electrodes are right on the gun. With an electric fence, those two electrical points are separated between the energized fence wire and the earth. If you touch it, you become like that small bit of fence being shocked between the electrodes on the stun gun. You complete the circuit. So, do you believe me yet? Yeah, I didn't think so. And I can appreciate the skepticism. So that's why I went ahead and went on Amazon and ordered one of these little stun guns. It looks fairly similar to the one that woman used in that video. And this thing definitely has a good enough kick to cause a lot of pain. So, what will happen if this gets discharged on the fence while somebody's holding it? Let's check it out. See? Told you. Didn't get shocked. Didn't feel a thing. Didn't fall to the ground. Didn't wet myself. Nothing. Again, that's because that current is trying to go from here to here. That's it. You may be thinking, oh, but that fence is in the ground. It was grounding, right? No. Again, this is a closed loop system with floating voltages. It's not trying to get to the ground because the ground isn't referenced. So, to prove that, let's shock some metal things in my hand and see if I get shocked. I'm firmly planted on the ground. So if I shock this, will it go through this knife, this butter knife, this metallic butter knife, through my hand to the ground? Let's find out. Nope. How about a screw? A little brass screw. Nope. Okay, how about a penny? Copper penny. Copper conducts pretty well. Let's see. Didn't feel a thing. Thanks for checking this video out. I hope you learned something. I know a lot of you were hoping to see me get shocked, and I'm sorry that, well, you know what? No, I'm not. I'm not sorry that didn't happen. If you want to learn more about electrophysics, electrical engineering, a little bit of that, you can check out some other content creators such as Electroboom. The guy's hilarious and he can teach you a lot about electrical engineering.